Revolution Radio. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hello and welcome back to Dave and Mackie's Shiny Side Up on Revolution.radio, show number 599. 990, excuse me, and 500. That's a lot of shows. That means we've been doing this roughly for 12 years.
Good on us.
12 long, unpaid years.
Please, someone
What?
throw money at us.
That who? What now? No, all good. Look, this is Listener Fun Radio. If you can donate, please do. If you cannot, that's cool. I dig it. Maybe someone you tell about the show can, or the radio station for that matter.
Folding money, by the way.
Yeah. Oh yeah, absolutely. Folding.
Don't throw coins.
No, nothing that jingles. If you can, great. You know, maybe you like Shiny Side Up. Maybe you like Plato's Cave. Maybe you like Solaris. We love Solaris. But maybe you like all the others. Jerbe is great. Others. I mean, there's so many good hosts on this station. There'll be something for everybody, and I'm sure there's something you'd love to hate. So don't feel shy about that either. You know, it's all good. It's all good. But if you can do, and if you cannot, please tell others. Maybe they can. Rightio. Now look, we have been talking about Lost Scientists for the last two. Yes, this is the third installment
part 3
of Lost, which actually is working out really good. Because obviously next week we're going to do the big show cycle again for show number 600. The great. What is it all about? Why is it happening? And where are we now? And then look, a lot has happened in the intervening since show 500. We had, 500, 2 years, 3 years, 2.5 years? Something like that.
Mm-hmm.
Because it's every full 100, we do one like this. And show number 500 in my archive tells me we did in January of 2022. So that's almost 2 years ago. Not quite, but pretty close. 1 year and 9 months, as it were, or 10 months by the time we get to it. So, missing scientists, because the thing is this, right? It is not what we're allowed to know that worries me. We are allowed to know about Einstein and relativity. We're allowed to know about quantum physics. Not that we understand it, but we're allowed to know about it, right? It's okay. And we're also allowed to know that the two don't go together. We're allowed that knowledge, right? What we're not allowed is other knowledge. And I think we've shown here fairly clearly that Tesla, there's at least some reason to believe there may be more to Tesla's work than we have actually uncovered as of yet. There were 80 crates that were packed and only 60 made it to his heirs. 20 crates of papers. I mean, I don't know how big these crates were, but even a small carton of, whatever it might be, can hold a lot of stuff, as you know. And 20 of them can hold a whole bunch of stuff. So there's that. Then we talked about the gentleman who was researching telepathy and who simply disappeared.
Yeah.
One day. And the only reason I knew about him is because I found an article on the CIA Freedom of Information site that referred to him.
Yep.
Now the article itself, of course, had something like 8 or 10 pages missing from the photostat. No, not redacted, just not photocopied, man.
The whole page was probably black, and they said, well, what's the point?
What's the point? Maybe, I don't know. All I know is if it was a mistake, please get better interns to do your photostats. Okay, just
$400 an hour.
Just concerned citizen. And he was mentioned also by certain Chinese scientists. Which, see, this is the funny thing, and I know I harped on about this last week, but
please do it.
Yeah, the experiment was conducted by a group of Chinese scientists, and they were referring to him, and it was looking at the connection of telepathy and quantum mechanics, if you will, right? I mean, other quantum processes that work here, for example, and so what the experiments were doing was not establishing whether or not telepathy exists.
It was already taken as fact.
Bingo. What they were trying to figure out, how does it work? What causes the telepathic effect, if you want to put it that way, but
sure.
Not whether or not telepathy exists. Okay,
they weren't questioning the results.
No, and they found that with a high degree of confidence, it looks like there is a quantum-related kind of thing, etc., etc., etc.
Mm-hmm.
Now, then we talked about the lady that had conducted research into anti-gravity-like machines. Now, she said she didn't find anti-gravity, but she found ways to manipulate gravity.
Yes.
Now, potato. If you can manipulate gravity, you might be able to negate it, which in my book is anti-gravity. But the point is, she was able, it seems, to manipulate
do two things: increase it or decrease it.
Yeah, and direct it, which was really interesting. And that kind of technology we've heard about on Star Trek. It's called inertial dampeners. So if you could direct gravity in the way that she does, you could create inertial dampeners for crazy maneuvers of spaceships, for example. Accelerations that are beyond Mach 12, Mach 15, Mach 100, whatever. It doesn't matter. If you can redirect the gravitational forces, the G forces, as it were, you could do that, and the people inside the craft wouldn't be ketchup. Okay, so that's really, and again, I can't stress enough just how important that kind of research would be, right? And then we looked at that, and she was a Chinese lady that had emigrated to the United States and had worked for the government, started her own company, and she was a prolific publisher of papers prior to working for the government, after which she published exactly nothing. And her son once asked her, Mom, he said, do you need to tell me something? And this is what she said to him, right? In relation to her research, of course. First off, you don't know anything. Nice, thanks, Mom.
Mm-hmm.
Second off, if you even think you might know something, you forget about it. So, first of all, she was telling him you don't know anything. She wasn't putting him down. She was telling him, listen, you don't know anything.
That's
like
right.
when you screw with a mob, you tell your family, you don't know anything, okay? Nothing, stumm.
You see nothing, you hear nothing, you know nothing.
And then she goes, even if you do, you think you know something, you forget about it, okay?
That's right.
It's like, I can hear that Brooklyn accent, right? You forget about it. Forget about it.
And apologies to everyone in Brooklyn.
Right. What you gonna do? I know, but it is really interesting that because clearly to her it's important, and you would think maybe not that if you do some work like this, which is groundbreaking as it were, you might want to leave it to someone, but clearly she knew that if she told her son anything at all, or if anybody ever thought that her son knew anything at all,
it would be to his demise.
It would be. Right. Now, this puts me in mind of one of my favorite books of the war, which is 20,000 Leagues Under the Sea. Captain Nemo, the inventor the creator of the Nautilus's submarine, used well, the way it was described by Jules Verne, it looked like a thermal energy. He used energy from volcanoes and magma, etc., to power his machines. How, it doesn't really go into the book, but it was such a great invention and such a powerful, creation that they tortured and killed his family, and he had no choice but to go underground and pretend to be dead himself. And then, and I don't know if you know the book, but what happened is the reason this whole thing starts, that there's this whale or the sea monster which sinks all these ships in the Atlantic, right? And this reporter goes in search of it and finds it's actually the Nautilus, the submarine. But what Nemo did, he was sinking all the ships of the people that had killed his family, and so on and so forth, right? And he had chosen anonymity, and he said, I'm not going to give my invention to humanity because, they're clearly not ready for it, they're not worthy of it. And funnily enough, Nemo is actually the Latin word for nobody.
Wow.
Captain Nobody, and he's concealing his identity, etc., etc. But the point is this. If you make an amazing invention, a discovery, like Tesla, like Dr. Ning Li, maybe, right?
Mm-hmm.
You are not safe. You're not safe, and we know this because other scientists, we haven't mentioned this here, but other scientists, the hydro, not electric, but the hydrogen engine, for example, water engine, etc., all the other stuff. These inventors actually disappeared and some were killed. Now people say, hydrogen is unstable, it's highly volatile. Now let's be very clear. Petrol is highly volatile.
That's right.
What happens with petrol when you bring it near a flame is it ignites, just like hydrogen. So the argument that hydrogen is not safe is a complete nonsense. It's no less or more safe than petrol. I'm sorry, but that's just the truth. Anyway, so we talked about a whole bunch of that stuff, and I think, Dave, we're up to breaking the law of gravity.
We are.
That's the attack. Okay.
That's where we are.
Why don't you get us cracking there, my friend?
You got it. Skeptics had a field day when a scientist claimed in 1996 that gravity could be negated. Now his findings are being investigated in laboratories worldwide. That same year, in 1996, Russian I don't know how to pronounce that, scientist Eugene Podkletnov.
He was just an immigrant. That's it. Yeah.
Oh, really? Okay. I wonder what role that they held in the Nazi Party. But anyway, so was about to publish a peer-reviewed article in the respected British Journal of Physics, proving, he claimed, that gravity could be negated. Skeptics had a field day, blah, blah, blah. It's the same thing. Now his findings are being investigated. In 1996, Russian Eugene was, that's the same. Then a London newspaper publicised his conclusions, and the skeptics had a field day. Everyone knew you couldn't mess with the laws of gravity. Einstein himself had said so. So, what happened? Podkletnov withdrew his article. His university evicted him. He retreated from the public eye. But the controversy hasn't gone away, and his findings began to be investigated in laboratories around the world, including one owned by NASA. Now, Charles Platt discovers Eugene Podkletnov is back and unrepentant. Shortly before dawn on a dismal, we'll fix that in post, rain-drenched winter morning, I'm heading out of Helsinki along Highway 3 into the heart of Finland. This obscure nation is an underpopulated wilderness, well, that's a statement, sandwiched like a DMZ between Russia and Sweden, extending all the way up into the Arctic Circle. The sun barely sets here in the summer, while in the winter it barely rises. I can't imagine why anyone would visit Finland in the dark months unless motivated by some strange need to go skiing in perpetual twilight. But my grueling pilgrimage has nothing to do with snow. I've come in search of a singular individual, a reclusive, elusive Russian immigrant scientist named Eugene Podkletnov, who claims that he can defy the force of gravity. 5 years ago, while testing a superconducting ceramic disc by rotating it above powerful electromagnets, Podkletnov noticed something extremely strange. Small objects above the disc seemed to lose weight. Weight is mass and gravity. As if they were being shielded from the pull of planet Earth. The weight reduction was small, around 2%, but nothing like this had ever been observed before. If the shielding effect could be refined and intensified, the implications would be immense. In fact, practical, affordable gravity nullification could change our lives more radically than the invention of the internal combustion engine. Imagine a future in which vehicles can levitate freely. Becky.
Sorry, just as an aside, Dr. Ning Li actually collaborated with Dr.
Really?
Yes. I think I should have said that from the start, but yes, they were actually collaborating.
Good grief.
As a little aside there. Anyway,
little.
No, okay, so highways and railroads become obsolete. Airplanes no longer need wings, and ocean-going ships can be broken up for scrap, obviously. Except we probably still want to have these nostalgic little journeys. Industries in which large masses have to be transported or supported, from mining to construction, are revolutionized. Citizens gain unprecedented mobility, transcending all geographical and national barriers. Now, just for a second here, guys, if you look at the world's massive stone constructions, all those monolithic buildings, especially in Baalbek, but not just there. Whenever you've got these 100 or even 1,000-ton stones, and we say how, and more importantly, why?
Mm-hmm.
If you had mastery over gravity, then it wouldn't even be a thing. I mean, whatever, right? Sure, of course you can.
Well, you can't distract gravity from these objects and just move them around like they were nothing. What?
Yeah, and just to be clear, if you can, and this is going to be covered in show number 600 and ongoing, but if you can do something, then chances are someone discovered it before us. Now let's think about this for a second. Just 1 second before I go on to the text. It took us good 5,000 years or thereabouts to get from rudimentary start of civilization to where we are today. Something like that.
Mm-hmm.
In the existence of the human species, in the acknowledged existence of the human species, which is now pushed back almost even 3 or 3.5 million years now, right?
Yep.
We could have done this hundreds of times.
Mm-hmm.
Hundreds of times, over and over. Just a small point there. Anyway, meanwhile, back to the text, space travel is now safe, cheap, and fast. Resources can be mined in the asteroid belt and shipped to factories relocated in orbit around Earth, freeing our planet from pollution and greenhouse gas emissions.
Hurrah.
Ultimately, the old dream of colonizing other worlds may be realized, not just for a handful of highly trained astronauts, but for millions of everyday people. Far-fetched? Indeed. Most physicists laughed at Podkletnov's report. Riley Newman, a professor of physics at UC Irvine, who has been involved in gravity research for 20 years, typified the reaction when he commented thusly: I think it's safe to say gravity shielding is not conceivable. Yes, and trains can't go faster than 30 miles an hour.
That's
like
right.
many scientists, he felt that Podkletnov must have made a mistake, measuring magnetic fields or air currents instead of genuine weight reduction. You know where else we have seen weight reduction, Dave?
Where?
White gold powder.
That's right.
White
Monoatomic
gold powder.
elements. Yes.
Yeah, we'll
Orbitally
cover that off
rearranged.
again, I think, at some point. And yet, few of Podkletnov's critics actually bothered to read his description of his work. It's like, no, but happens a lot. Oh, that's impossible. It's crazy. Rather than actually looking at the evidence, seeing, giving it like some meaningful criticism, it's a blanket nonsense.
That's right.
I hate people. Anyway, their reaction was so dismissive, it almost sounded like prejudice. Almost. From their perspective, he was an outsider, a non-member of the gravity establishment. They couldn't believe that a major discovery in physics had been made by such a no-status dilettante fooling around at some obscure lab in Finland. True, Podkletnov wasn't a physicist, but he did have a doctorate in materials science, that is. And he knew how to do careful lab work. When he wrote up his results, his papers were accepted for publication in some somber physics journals, and at least one theoretical physicist, an Italian named Giovanni Modanesi, became intrigued. Modanesi didn't dismiss the whole idea of gravity shielding, because on the subatomic level, we simply don't know how gravity functions. Thank you for that honesty. What we are lacking today, according to Modanesi, is a knowledge of the microscopic or quantum aspects of gravity. It always comes back to quantum, doesn't it? Comparable to the good microscopic knowledge we have of electromagnetic or nuclear forces. In this sense, the microscopic origin of the gravitational force is still unknown. At the Max Planck Institute in Munich, he developed a theory to explain the shielding phenomenon. In the United States, scientists affiliated with NASA were thinking along similar lines. They obtained funding to replicate Podkletnov's experiment. But still, the skeptics remain cynical and unimpressed. The concept of gravity shielding has an aura of science-fictional weirdness. It sounds like something out of the X-Files. Indeed, Podkletnov's experiment was actually mentioned in an episode of the X-Files, virtually guaranteeing that most scientists wouldn't take it seriously. Now, just on a side here, we discussed this. As soon as you make it part of popular culture, like a TV show, a movie, or whatever,
that's right.
it can't just be dismissed. Oh, it's just a movie. It's just a TV show. That happened actually with a lot of stuff, everybody. A lot of stuff. Now, Podkletnov now claims that his results have been verified by researchers at 2 universities, but he won't name these people for fear that they'll be ridiculed and ruined by the gravity establishment. Think about that for a second. The team at NASA makes no secret of their work, but they have no definitive results yet. And so at this time, the only credentialed scientist claiming to have witnessed gravity modification is Podkletnov himself. For almost a year, the author, have been wrestling with this story, which is a journalistic nightmare because nothing can be verified. Podkletnov may have made one of the great breakthroughs of the 20th century, or he may be suffering from a severe case of hubris coupled with wishful thinking. In darker moments, I wonder if he even exists. The whole gravity story could be a prank by a bunch of hackers using a fake email address and a Finnish phone number that auto-forwards calls to a dorm at MIT. These thoughts run to my mind as I pull off Highway 3 into a rest area, crack a screw bottle of Vichy water, and check my map. It's now an hour after dawn, but the light is still so dim. The scenery outside is all shades of grey, as if I'm trapped inside a monochrome TV with a brightness control struck near 0. In Finland, the winter, when the sky is totally choked with clouds, the country becomes one big sensory deprivation tank because it's so close to the Arctic Circle, of course. On the car radio, some nameless station plays authentic American bluegrass, except that the lyrics are in Finnish, which is a head-bending experience. The last thing I need right now. Still, having come 5,000 miles, I'm determined to see this through. In just a few hours, I'm scheduled to meet Eugene Podkletnov in person in the town of Tampere, where his gravity modification experiments took place. I will verify, if nothing else, that he does exist, assuming, of course, that I can find Tampere in this drizzle-soaked wilderness of unidentified gloom. Dave?
Gravity shielding isn't a new idea. H.G. Wells explored its potential for spaceflight almost a century ago in his classic novel, The First Men on the Moon. Wells also foresaw an avalanche of applications on planet Earth, creating an uneasy conflict between pure science and pure greed. Don't we see that? In his novel, A lone mad scientist says he isn't in it for the money. He just wants some recognition and maybe a prize or two. But then he starts to realize just how much money could be involved. I suppose, he says thoughtfully, no one is absolutely averse to enormous wealth. Eugene Podkletnov must be aware of this, but so far he has reaped more pain than profit. After publishing a preliminary paper in 1992, he wrote a more thorough paper that was rejected by more than a dozen journals, till finally it penetrated the peer review process at the respected British Journal of Physics. This deemed to offer the recognition he was hoping for, yet instead it initiated a career-destroying nightmare. I do actually remember hearing about this around that time. Believe it or not. There was also a guy that had 3 rotating discs in a box that seemed to levitate as well. The box levitated, but a different thing. So the trouble started when Robert Matthews, science correspondent to the British Sunday Telegraph, got hold of the story. Matthews, like any journalist, relies on contacts, and he's disarmingly honest about it. He says, you don't get stories by digging for them. He now says with a laugh, this isn't like Sherlock Holmes. That's a lot of bollocks. It's like you hope a little brown envelope turns up in the post, and if it does, you're in luck. In this case, a little brown envelope contained page proofs of Podkletnov's paper, leaked by a man named Ian Sample, who worked on the editorial staff at the Journal of Physics. Although Podkletnov's paper hadn't been published yet. Sample and Matthews decided to break the story in the Sunday Telegraph, which printed it on September 1st, 1996. The first sentence was key. Scientists in Finland are about to reveal details of the world's first anti-gravity device. There's the headline. Anti-gravity? Podkletnov never used that word. He said he'd found a way to block gravity. Maybe this seemed a trivial distinction, but not to the staid professors at the Institute of Material Science in the University of Tampere, to whom anti-gravity sounded like something out of a bad Hollywood movie. The director of the institute promptly denied any involvement and declared that Podkletnov was working entirely on his own initiative. Then, the co-author of Podkletnov's paper claimed that his name had been used without his knowledge, which was highly implausible, but he stuck to his story presumably because the institute told him to. In the end, Podkletnov had to withdraw the paper from the publication in the journal. He was abandoned by his friends and his credibility was impaired. At this point, I, the author, obtained Podkletnov's phone number in Tampere and gave him a call. He turned out to speak fluent English, but was reluctant to say anything, claiming that irresponsible journalism had ruined his career. Don't blame him. I gave him various assurances, faxed samples of my work, made more calls, and finally on November 10th, hang on, how many days is that? September 1st, and then it went to, November 10th. 1996, he gave me a telephone interview. He told me how he had made his discovery. Quote, someone in the laboratory was smoking a pipe, he said, and the pipe smoke rose in a column above the superconducting disc. So he placed a ball-shaped magnet above the disc attached to a balance. The balance behaved strangely. We substituted a non-magnetic material, silicon, and still the balance was very strange. We found that any object above the disc lost some of its weight, and we found that if we rotated the the effect was increased. I had no way to evaluate the truth of this, so I contacted John Kramer, a physicist who was familiar with the story. Quote, "I don't believe he has discovered a shield for gravity," unquote, Kramer told me, insisting that huge amounts of energy would be required. That's always the great excuse. You can't go faster than the speed of light. It's impossible. According to the equations, you're going to need infinite amounts of power. That's always the description. And just remember that the train that goes 28 miles an hour and kills all the occupants because it causes vacuum, that's what my grandmother told me, was the science at the time. So ridiculous. But they believed it, and they refused to get on the train to prove it or disprove it.
Yes.
Back to the story. I checked back with Podkletnov. He quotes, "We do not need a lot of energy," end quote. He said, sounding irritable, as if it were wasting his time with dumb, obvious questions. Quote, "We don't absorb the energy of the gravitational field. We may be controlling it, as a transistor controls the flow of electricity. No laws of physics are broken, or is broken." Grammar. I'm not one crazy guy in a lab. We had a team of 6 or 7, all good scientists, unquote. So why should I believe? Maybe if I met Podkletnov in person, I could assess his plausibility. But a few days later, he told me this was impossible. In fact, he said, he had decided that he wanted no further publicity of any kind. This put me in an impossible position. Podkletnov had talked to me originally because I pledged to publish nothing about him without his consent. Now that he had withdrawn his consent, I simply had to honour my pledge. Temporarily, at least, I abandoned the story. Months passed. Once in a while, I sent an email to the Italian physicist Giovanni Modanesi, who seemed to know where Podkletnov was hiding, but Giovanni just confirmed that the reclusive Russians still wouldn't talk. Finally, by chance, I read a Usenet message from a 34-year-old software developer in Oregon named Pete Skeggs, who turned out to be a pivotal figure in a newly emergent net phenomenon, the anti-gravity enthusiast underground. Mekki.
Skeggs had a Bachelor of Science in Electrical Engineering, a Bachelor of Science in Computer Science, and he loved to tinker with things. In his own little workshop, he had tried to replicate Podkletnov's experiment using some homemade electromagnets and a 1-inch superconductor that he ordered from the Edmund Scientific Mail Order Catalog for $24.95 US. He didn't get any results, but decided to start a gravity modification webpage. Soon it was a huge repository of abstracts, speculation, and references, along with reports of work by other amateurs, some of whom claimed amazing results. A man named John Schnurrer at Antioch College in Ohio said that his homemade setup could reduce the force of gravity by 2% on a reliable, repeatable basis. I sent email to Schnurrer. He replied enigmatically, refusing to divulge his home or office phone numbers and insisting that I must page him, after which he would call me back. On September 17, 1997, he returned one of my calls. Aged 45, Schnurrer said he had a strong science background, though he admitted he had no college degree. He claimed to have co-authored more than 12 peer-reviewed papers and had spent more than 9 years providing tech support for Armstrong Aerospace Medical Research Labs at Wright-Patterson Air Force Base.
Wow.
Where they had been trying to find ways for pilots to control airplanes via brainwave sensors.
Yes, I know about that research.
Yep. We had a flight simulator, Schnurrer said. You could sit in it and make it roll with your brainwaves. However, he had been laid off in 1995 because of budget cuts, and he was frank about his current problems. I don't have any money, he said. Most of my equipment I built myself or borrowed or resurrected. Still, he claimed that his redesigned version of Podkletnov's setup was working on a routine basis and could be used on board Earth satellites to make small orbital corrections. Was Schnurrer for real? He agreed that I could visit him, so I arranged for Wired photographer Norman Mouskopf to meet me in Ohio. A couple of days before my trip, I contacted Schnurr just to check that there were no snags, and he assured me his apparatus was still up and running. I have enough liquid nitrogen for one run, maybe two, he said. This made me suspicious. 2 demos could be just enough to show more results while preventing a more thorough investigation. I sent email asking Schnurr to obtain more liquid nitrogen. I even told him if he didn't have the money, I'd pay for it myself. 2 hours later, he called and said, "Can you wire me the cash via Western Union?" He said, "I need $150. Well, I'd been dumb enough to make the offer, and I was determined to witness a thorough trial, so I sent the money.
I'd be dumb enough to send the money.
2 days later, indeed. Actually, that sort of reminds me of me. 2 days later, I was in a rented car with Norman Mauskopf driving across the flat farmland of Ohio to Antioch College, just south of Dayton. Dayton, Ohio, wow. We found Schnurr in a fine old red brick residence with white painted casement windows and a big front porch. This turned out not to be his home. The place had been divided into offices. Schnurr's workshop was in a long, thin sunroom where a white painted wooden bench left barely enough space for people to squeeze past each other. The bench was strewn with components, tools, computer circuit boards, books, and loose-leaf binders. At the far end stood the gravity modification machine. A long wooden rod was pivoted on a nail, supported by a wooden yoke, glued to a block of plywood. A piece of string dangled from one end of the rod, tied around a lump of scrap metal. At the other end, a tangle of fine wires ran down to some coils underneath a 1-inch black disc, a superconductor that had been donated by a local manufacturer, thus saving Schnurr the $24.95 charged by Admin Scientific. When asked why he had to economize so stringently, he muttered something about his family not fully sharing his enthusiasm for gravity research. The wires from the electric magnets snaked back to a 12-volt power supply, via a switching system consisting of bare copper contacts that had to be maneuvered by hand. "You can't photograph that," Schnurr said firmly. "That's an integral part of my patent application." I stared at his apparatus in dismay. Even straining my creative powers to the limit, clearly there was no way to portray this as cutting-edge science. The components looked as if they had been salvaged from a dumpster. Schnurr, however, was eager to begin. He showed me his target mass, a bundle of 7 glass rods, which he placed ceremoniously on a borrowed digital scale. He noted the readout, 27 grams. Then he picked up a small tank of liquid nitrogen, my liquid nitrogen, I realized, feeling a bit pissed about it, and he poured a portion into a Duo flask. The liquid hissed like oil in a hot frying pan as it boiled violently at room temperature.
Mm-hmm.
We waited a few minutes for the clouds of white vapor to die down. "Now," said Schnurr. He lowered the electromagnets, disc, and target mass into the Duo flask to cool the disc so that its electrical resistance would diminish to 0. Then he placed a lump of scrap metal on the scale to read the difference in weight between it and the assembly of the Duo flask. The numbers flickered wildly, responding to the thermal currents in the liquid. Air currents in the room, vibration from a truck passing on the road a couple of 100 feet away, and a dozen other random factors. Still, a substantial weight reduction would make these small fluctuations irrelevant. "We'll call the weight 20.68, Schnurr said, scribbling the figure. He went to his copper contacts and started manipulating them to send pulses to the electromagnets. I watched the scale and suddenly felt as if reality was warping around me because the numbers began changing. According to the scale, the target mass was getting lighter. "Write down the peak value," Schnurr alerted me. The numbers were still jumping, but I averaged them as well as I could. Schnurr grabbed his scrap of paper, did a subtraction, divided the result by the original weight of the target mass, and got his answer. Here, in this funky little workshop, the force of gravity had just been reduced by 2%. Now, sorry to break the text here. That's actually significant, everybody, because gravity is a constant force on this planet. And to reduce it or increase it is quite extraordinary. "Let me try that," I said, pointing to the copper contacts. Schnurr stepped aside, looking somewhat reluctant, but when I did what he had done, the results were the same. Maybe you should take a look over here, Norman Mauskopf remarked, nodding toward the superconductor where it dangled in the liquid nitrogen. I realized with chagrin that I had been totally hypnotized by the red LEDs in the scale. When I turned my attention to the flask, I saw what I should have seen before. Electricity flowing through the submerged coils was creating heat that made the frigid liquid boil, just as eggs bounce around when you boil them in a saucepan. The superconductor and its target mass were being lifted by the bubbles. We weren't measuring gravity reduction here. We were conducting an experiment in cryogenic cookery. I pointed this out to Schnurrer. He looked annoyed, then indifferent. I realized that there was still no doubt in his mind because he was a true believer. He knew he was modifying gravity. So we'll lift it out of the liquid nitrogen, he said. It'll stay cold enough for the effect to work for 15 or 30 seconds, and you'll see it will still get lighter. We tried it, and sure enough, the assembly lost weight. But it had dragged some liquid nitrogen with it from the flask and was steaming madly. This was not a source of weight loss, just as damp cloths becomes lighter as they dry on a washing line. John, you're not measuring gravity fluctuations, I told him. You're measuring the effects of boiling and evaporation. Schnurrer was now visibly agitated. He wanted to run the experiment again and again. He varied the target mass, scribbled more numbers on odd scraps of paper. After a while, there were so many scraps, he lost track of which was which. For several hours, he tried every conceivable configuration. Dave?
While waiting patiently to see how long it might take him to admit defeat, I noticed a page from Business Week lying on his workbench. It was an article about gravity modification, mentioning Schnurrer's work. Illustrated was a photograph taken right here in his cramped little hobby den. Although false colour and a wide-angle lens made the place look like a futuristic laboratory. Then I scanned the text and realized that this writer possessed the creative powers that I so sadly lacked. He seemed cautious and objective, yet made Schnurrer sound like a fully qualified scientist, even identifying him as Director of Physics Engineering at Antioch College, the Holy Hand Grenade of Antioch. I queried Schnurrer about this. Gruffly, he told me that he has never been employed by Antioch University. His workshop just happens to be near Antioch. With several partners, he runs a very small company named Physics Engineering, of which he's a director. Only in this sense can he be termed a director of physics engineering. Around 9 p.m, we called it quits. I didn't enjoy being a heartless skeptic, questioning John Schnurrer's credentials and debunking his dreams of refuting Einstein. I just wanted to go home. Back in New York, 3 pieces of email from John Schnurrer were already waiting for me. With urgent sincerity, he claimed there had been a series of unfortunate errors. The superconductor had become degraded. The results I witnessed were invalid. He begged me to return to Ohio right away to witness a whole new series of experiments with a brand new disk. Well, thanks but no thanks. I didn't relish another session of skeptic versus true believer. I felt sure that it wouldn't work out any better the second time around, and it wouldn't make either of us very happy. Instead, I followed up another reference from the... Oh, what's that word?
Indefatigable.
Thank you. Pete Skeggs. And learned the strange history of NASA's involvement in gravity shielding research. In 1990, a senior scientist at the University of Alabama named Douglas Torr started writing papers with a Chinese woman named Ning Li, predicting that superconductors could affect the force of gravity. This was before Eugene Podkletnov made his observations in Tampere. So naturally, Li and Torr were delighted when they heard that Podkletnov had accidentally validated their predictions. Their university enjoyed a good working relationship with the Marshall Space Flight Center in Huntsville, where they eventually persuaded NASA to start a serious long-term investigation. Ning Li remained involved while Douglas Torr relocated to South Carolina. Skeggs now forwarded to me an amazing document suggesting that Tor had ventured into even stranger territory. The document was anti-gravity news and space drive technology. The amateur Zine that looked like a 1970s counterculture manifesto generated on an old daisy wheel printer, pasted into pages, photocopied and stapled down the left edge. The science-orientated Samizdat, which was a hopeless muddle of wacky ideas and grandiose claims, but on its back cover it reproduced an announcement from the Office of Technology Transfer at the University of South Carolina. Incredibly, this text described a gravity generator that would create a force beam in any desired direction. The announcement concluded, "University seeks license and/or joint development. USC ID number 96140. At the bottom of the page was a phone number for William F. Littlejohn at the Office of Technology Transfer. So I called it and reached an assistant named Frances Jones. Sounding not very happy, she confirmed that the announcement was genuine. But Mr. Littlejohn says it was presented prematurely. It got wider distribution than we intended, and we're still working on the technology and would prefer not to receive any publicity." She refused to say if Douglas Tor was involved, but on the university's website I found an annual report to the Faculty Senate which listed his name on a patent application for the gravity generator. This was totally bizarre. A respected university supposedly looking for commercial partners to develop a gadget straight out of the 1950s science fiction novel? Surely nothing could be weirder than this. But no, there was more in store. Through a physicist friend, John Kramer, I learned of a scientist named James Woodward, who claimed to have found a way to reduce massive objects. Mass? Doesn't that mean the same thing as weight? Well, no, actually, mass...
No, mass doesn't mean the same thing as weight, is what the text tells you.
Mass is the amount of something, and weight is the amount of the thing affected by gravity. That's how you measure things.
And the text says mass doesn't mean the same thing as weight.
It doesn't mean the same thing as weight. You'd weigh less on the moon than on Earth because weight depends on the force of gravity. Mass, on the other hand, is an innate property of matter. It exists even when an object is in freefall. Nevertheless, Woodward had written a paper claiming that he could adjust the mass of an object. Foundations of Physics Letters, Volume 3, Number 5, 1990. And he even managed to get a US patent for his device, number 5280864, issued January 25th, 1994. I called him at his office at Cal State Fullerton. In fact, that's where my parents' friends were both professors.
Nice.
And I knew the sociology professor, the math professor, and another math professor. Where he'd been affiliated for 25 years and is currently an adjunct professor of physics. He turned out to be a jovial, amiable man who was more than willing to talk on the record, probably because his work has remained so obscure, no one has had a chance to ridicule it yet. Mekki.
The equipment he uses is relatively simple, which is just as well since he's had to pay for a lot of it himself. If you want to reduce the mass of an object in the privacy of your own basement workshop, here's how it's done. Obtain a high-tech ceramic capacitor, a standard electronic item, and attach it to the speaker terminals and a stereo amplifier, feed in a steady tone, perhaps from one of those stereo test CDs, while using some kind of electromechanical apparatus, maybe the guts from an old loudspeaker, to vibrate the capacitor up and down. According to Woodward, the capacitor's mass will vary at twice the frequency of the signal, so you will need a circuit called a frequency doubler to drive your vibrator at the correct rate. If the vibrator lifts the capacitor while it's momentarily lighter and drops it while it's heavier, you achieve an average mass reduction, which sounds as if you're getting something for nothing, except that Woodward believes that in some mysterious fashion you're actually stealing the energy from the rest of the universe. I asked him why no one had ever noticed that the weight of capacitors varies in rhythm with their energy level. Well, he said, people don't normally go around weighing capacitors. Fair point. He claimed that so far he's measured a reduction of up to 150 milligrams, just a fraction of an ounce. Still, practical applications could be developed. If someone decided to put substantial amounts of money into this, you could have something within 3 to 5 years. For spacecraft, all you'd need would be big solar arrays instead of rocket fuel. I asked him if there was any chance that his discovery might turn out to be bogus, like cold fusion. Of course, he said, laughing cheerfully. I have bi-weekly paranoia attacks, and then I try something else to see if I can make this effect go away. But it won't go away. I asked his opinion of the team at NASA. Serious and competent, sensible folks, he said, though he seemed to find gravity shielding a bit implausible even compared with mass reduction. Clearly, it was time to call NASA. I contacted David Nerver, a theoretical physicist and former Rhodes Scholar who started working with NASA in 1987 after getting a PhD at Oxford University in England. He seemed to be the key figure trying to replicate Podkletnov's work, and he invited me to see for myself. The Marshall Space Flight Center is a box-shaped 10-story office building with a 1960s pedigree. The closer I came, the shabbier it looked. When I walked up the front steps, I noticed cracks between the faded grey panels of his facade. Alas, poor NASA. Formerly the favorite child of federal legislators, now nickel and dimed half to death. Upstairs I found utilitarian government-style offices with cheesy rubberized floor tiles, ancient grey steel desks, and file cabinets that seemed to have been repainted by hand. The place was almost Soviet in its austerity. I entered the office of Whit Brantley, chief of the Advanced Concepts Office, and found 5 people waiting around a wood-grain Formica conference table. David Nerver was one of them, a tall, brooding figure with intense eyes and dark brown hair in need of a trim. Behind a desk at the far end sat Brantley, a genial Santa Claus who joined NASA back in 1963 when he worked on von Braun's wildly ambitious scheme to put men on Mars before the Apollo program had even test-launched its first capsule. Even this seemed relatively normal, though, compared with gravity shielding. I asked him how he had raised the money for such a wacky idea. The first research proposal I wrote didn't have the word gravity in it anywhere, he said with a grin. Then the Sunday Telegraph article came out, and our administrator, Golden, was going to a Star Trek convention where the Trekkies might ask him about gravity modification, so we decided to tell him what was going on. He backed up a step or two, then said he thought NASA should spend a little money on work like this. So we wiped the sweat off our brows and continued. Tony Robertson, another member of the team, leaned forward, a lot younger and more earnest than Brantley. The way I see it, he said, NASA has a responsibility to overcome gravity. Right, said Brantley. We've been building anti-gravity machines since day one. It's just they're not as efficient as we'd like them to be. Everyone chuckled at that. It's true, we're pushing the edge, Brantley went on, but the only way to guarantee you don't win the lottery is don't buy a ticket. So true. I turned to David Nerver, who looked tense and restless, as if he'd rather be in his laboratory. I asked how he felt about amateur gravity enthusiasts. Well, we went to visit John Schnurrer, he said, but he wouldn't let us in. We had to meet him outside on a park bench. We also invited Podkletnov to come to Huntsville back in January 1997. We said he'd pay his way, but he said he didn't see any value in it. It is not uncommon for people to just trust NASA, said Brantley, because we're part of the government. They think even if we did discover something, we'd cover it up. You know, Roswell and all that. By this Tim, however, was definitely ready to go. Let's show you the lab, he said. He led the way outside to an enclave of austere, ugly concrete buildings that looked as if they might have been left over from World War II. Inside the past Inside, past massive machinery for pressing ceramic discs, I entered a lab of about 20 square feet, with one wall of windows, fluorescent ceiling panels, big white cylinders of liquid helium and liquid nitrogen, and heavy-duty rack-mounted power supplies in rectangular metal cabinets.
Oh, you're going to have to stop it there. The music's going to start any second.
Oh, no!
There it is. Guess what?
Oh,
We're going to
hot
continue
dog.
this in show 601. Next week, we're going to have show 600, big celebration, and you'll find out a lot there. In the week, we're going to have Plato's Cave, 7 a.m. Eastern Time on Tuesday and Thursday. Catch us then too. Coming up next is Jer Bear with his awesome show After Hours. We're going to have a safe week if you can. This has been David Mackey's Shiny State.